Um, we're going to talk about switches some more. So we'll still be working with the common, normally open, and normally closed contacts like we have been, except this week we're going to be focusing on sprinkler equipment. And thanks to Terrence and Colin, they've helped me procure a couple common parts that we're going to be able to use for a hands-on demonstration. This here is an OS&Y valve. It's a pretty common type of switch used with sprinkler valves, PIV switches, those sort of things. So I'm going to show you a little bit of the overview of how it needs to be set up. Not that we do a lot of setting these up. Normally, in our lineup, in our area, the sprinkler contractor takes care of this, but sometimes it's helpful to know how it's supposed to be set up so that you can identify when it's not set up correctly and you can help have that correction made properly. And there are other areas, some other times when you might actually have to mess with one yourself. I've had a couple of service calls where I've had to adjust the valve or the switch rather with the valve. So there's a couple things to point out. First of all, you actually have, if autofocus would cooperate, that would be nice. You have two sets of switches because you have common, normally closed, and normally open that are these three terminals on this side. And then a separate switch you have normally open, normally closed, and common on this side. So if you're using this common, you need to use these two terminals. If you're using this common, you need to use those two terminals. And then over here, down here underneath, you see those little orange bits there? Those are actually the switch. So there's this, come on, I really wish this focus would work better with me here. As this goes over, it actually pushes the switch up. Let me see if I can get it to sit on it. So you see when it sits right there, it pushes that switch in, and this is how it's supposed to normally be set when the valve is in the open condition, you know, whenever it's open, letting water flow through the way the valve should always sit. That switch should be pushed up. And then as you start to close the valve, it slides it over and releases it, and that's when it changes state. But if you notice, when there's no pressure put on this at all, that switch is also left in its not resting state. That can sometimes cause some problems if it's not set up properly. I've had them set up before where they were set just like this, where it's about to push the switch, and then you get going and it makes it change condition, and then you go and you get the valve all the way closed and it goes back to how it was before. And that's not how it's supposed to be. And on this particular valve, this is a Potter brand, I believe. You see right here, there's this part, and there's a little window. Whenever it's actually set correctly and that valve is all the way open, there's that little white identifier that you can see through the window. And if you go too far on either side, you see that white doesn't fit quite right. So that's a really quick identifier to know if the valve is set correctly or not. So the way this works, this mounts on the outside. You get like a U-bolt or a couple bolts and a bracket that holds this actually against your valve. And this protrudes in there. And there's a armature thing that as you open and close the valve, it pushes and pulls this back and forth. And so there's actually some adjustment where you take the face off the valve and you spin the block down the threads, and you get it so that it's set just right to where it's holding it right there where it needs to be while the valve's all the way open. And then as you crank it in, it releases that switch. So this little black part right here, and there's a second one here, are your actual switches. And then these are just terminals to make it easier to wire onto the switch. And everything else is about activating that little orange button. So I'll turn the meter on real quick, and we'll use the meter as our monitor module as we have been. And I'll try to get this on here where you can actually see it switching states. So the way this needs to work in order for the signal to be read across, so we always have to use the common terminal, and then we have to choose between the normally closed and normally open. So I'm going to try to clip this on here. I don't know if I'm going to be able to do that with that resistor. I was trying, but it's not working. Where's my other alligator clip? See if I can make that work. I can't. Okay. So I'll put this under here, and I'll just try not to mess up my meter leads. So I think that's a clear enough view. What I did was I put my meter leads under common and normally open, which right now on the meter you're seeing 0.1 ohms. And so it's actually in a shorted condition, which would not be an open terminal. But like I said, whenever there's no pressure on this, it's not in its resting state. I have to slide the thing over to push that orange part up. So now I've got it held. You can see that orange part underneath is being pressed. So it's OL, open line. And so that's common and normally open. If I were then to get the resistor to sit between those, this is when we would read the resistor. And then as you turn the valve, it would slowly push on it and you'd hear that click and it shorts. When it shorts, that's when we get our supervisory or alarm signals, is when our meter reads a short like it is right now. And then you let it back up a little bit. And then we go back to that open line. And if I let it back up more, it goes back to that shorted condition. So if you're ever working at a time where it's sitting like this and you realize, hey, I have to be on the normally closed, here, I'll move it over so you can see what I'm about to describe. So now I'm under normally closed and common, and you see I have the open line. And so if you ever have it sitting right here and you've got it reading your resistor, and then you start turning the valve, whoops, going a little too hard there, and it shorts and you get your supervisor and you're like, yeah, okay, that's good. And you close the valve all the way and it goes back to open line, that supervisory clears. That means that that the switch is not set up right inside. So you might need to get with the sprinkler contractor and show him this. And so you'll be able to see right here, I'm going to demonstrate that same thing. So I have it sitting against that little orange part right inside there. Whoops. And so I start turning the valve and it's, hold on, there we go. And it pushes it so everything seems like it's working, but as I keep turning it and keep pushing it, and it closes all the way, and it actually returns back to a normal condition. That means that it's not set in the correct resting state. The other thing I see is you get it, sometimes they'll set it where it's like right here on the edge so that everything reads right. Right now you're reading a short because I have it wired backwards. But you turn that valve maybe a quarter turn and then it clicks to that, and then you can keep going all you want. You can close that valve all the way and everything still works right. But if you get that set, especially on like a wall PIV or something where it's accessible to the public, if it's set too close to that line, that can actually cause some problems for the customer, because if someone, say, just walking down the street and they brush their shoulder against this, then now it's sending their panel in and out of supervisory all the time, and that's gonna be a nuisance. So here, I'll move this over one last time back over to the normally open, how it's supposed to be wired. And let's see if I can make that resistor sit on here, and I'll show you how it goes from reading a short to reading the resistor, just so you can see that with your own eyes. Come on. Let's see if that'll... Trying to get it to where I can hold it with one hand so I can move it with the other. Okay. So I'm going to move it real quick. All right, so right here, this would be its normal resting state, wired up correct. This is a 4.7 k ohm resistor. You see it's 4.661 k ohms on the meter. And so this would be the valve is all the way open. And then I'm going to start turning it and closing the valve. And there we go. It clicked and it went to a short. So you can see how the electricity is able to go across the resistor when it's an open condition. So there would otherwise be no continuity between the two. But whenever a path of least resistance is available, the direct short, it takes the direct short instead of going across the resistor. That would essentially be taking a jumper like this and doing the exact same thing. So see, now I'm right here, that goes from an open line, and I put that short on it, and you're able to see that it takes the short instead of that open because it's providing a path. So then whenever I go and I let the switch actually do an internal short, it's the exact same thing. And so that would be like if you have the choice of going through that resistor or going through this short, the electricity will always choose the short because the short is easier than the resistor that I just made jump for no reason. So that's all I've got for the tamper, but I also have a water flow. So I'll show y'all how the water flow kind of mounts up. It's much easier to set up. There's not an actual calibrating process to it or setting the switch in the correct position. So this is the water flow switch. Back here, you can see there's flow indicators. So that's the direction of the water flow. It only works one way. And this is the paddle that the actual water pushes on. This right here is a rubber grommet that seals against the hole. The hole in the pipe is only this size. And so the paddle actually has to fold up to get pushed in there. And then when it sits in the pipe and the water flows against it, it can push it up and down. And then here on the front, this is the part we're more used to working with. See if I can get it to where you can read it real quick. Maybe if I... All right, it's not cooperating, sorry. But over here you have common is that first screw, normally closed is the second, and then normally open is the third. And then it's just reverse order. So you have common, normally closed, normally open. And again, it's two separate switches. So if you use these three, you can only use these three. And if you use those three, it is a completely separate circuit. And then down here on the bottom, this is actually how we adjust the time delay. So set it 0 right now. There is no time delay. Whenever this paddle gets pushed, it immediately changes state. And then if I turn it a little bit and I hold it, there's a timer in there, and then it releases. And I don't know if you could hear that, but it just clicked, so it just released. And then you can crank it up quite a bit, all the way around to that max right there. So right now I have it on 0, so there's no delay. This little red thing, just like on the tamper, that would push out, and that would be where your conduit comes in. There is this other knockout that looks like it's ready to be punched out. They're a complete pain. It's easier just to drill them out, in my opinion. So that's if you had to have your conduit come in here and then daisy chain out to, whether it's down to your tamper for that riser or to a second water flow on maybe a riser sitting right next to it. So if you ever have to use that second knockout, it sucks. Just plan on drilling it out and not trying to knock it out with your screwdriver or something. So wiring up to supervise this with your meter or with your monitor module works the exact same way. You still use common, which I'm going to put positive meter lead under the common terminal here, and you use normally open. And here, I'll try to hold the resistor across it so you can see there's that 4.6 k ohms. I'll turn it. There's not a good way with my hand. So I have it on that common here and normally open here. This thing is awkward shape. Sorry, guys. So there's that 4.6. And then if I move this paddle, see, I have no time delay. So it goes right to that alarm. And I let go of it. So there's nothing that's going to actually have to be set or adjusted or like that other valve, except for this timer. And the point of the timer is going to be water pressure. So city pressure, especially, I'm going to leave this on here actually, because next part will still use that. City pressure goes up and down with the water. I know in the city of Santa Fe, I don't know if this is still the case, but a story I heard from my stepdad a couple years ago, he's part of the fire department there. And he was saying if they hook up to any of the fire hydrants on one side of the town, it actually activates the water flow alarm at the high school, because the city pressure drops so much that the pressure there in the sprinkler system of the high school would drop a lot. And then whenever they close the fire hydrant, the pressure would be able to build back up and it would activate the water flow alarm. And so I don't know if that issue's been resolved. We don't service that school, so I never went in there and messed with it. I wouldn't be surprised if it was fixed by now. I would really hope it is. But that's what this timer is for right here. So you can adjust that delay so that it has time that as the water pressure fluctuates up and down, it won't set the alarm off. It'll let the water pressure move so that this switch kind of goes back and forth a little bit flowing with water, but it won't actually set it. So instead, if you were watching right there when I was doing that, you could see that went into alarm just as soon as I touched it and started moving it. And if I set that timer right here, that allows pressure to build back up and it moves the paddle and then it stops and returns, and it never went into alarm. But you can set it short enough so that if water is actually flowing, there's just a little bit of a delay and then it'll switch into alarm. I don't know how long I have this set for. There we go, it switched. And so that's what the time delay is for, is so that you don't get false alarms from things like changing water pressure. Water pressure can also change if there's dramatic temperature changes. Just like your car's tire pressure, sometimes you got to air your tires up on your car whenever the temperature drops too much. Water changes the exact same way that air does in that situation. And around here, we have our days where we wake up in the morning and we crank the heater, and then, you know, a few hours later, we're turning the air conditioner on. So water pressure can go back and forth for that. Now the tamper, we don't really use the second side of the switch very often, but the water flow switch we sometimes do. Now I'm going to bring back the fancy LED trailer light that I was using a couple weeks ago. Here, let me get my meter leads out of the way. That's just going to cause a confusing mess. And we're going to pretend that this is our water flow bell. Now I'm using the LED light instead of a water flow bell, even though I could just walk to the other side of the door and grab a bell. Honestly, I don't want the hearing damage from the bell being this close to my face, and I just don't want to listen to it. If I'm just being really honest, that's why we're using a light instead of a bell, because this is silent. So the first thing to know about hooking anything up that we're going to switch the power on and off to is one side of your circuit always goes straight to your power side. You only switch one side of it. So this black wire here is our negative side of our circuit. So I'm going to run it, and I'm just going to hook it up to the negative side of this battery. I'll put the battery right down here so you can. I'll try to do something so you can see. So I have my black wire going to the negative side of my battery here. Then this wire right here that I have a terminal on one side and just bare wire on the other, that's going to be the positive coming from the battery to my switch. So what I talked about before, whenever we brought, here I have it right here, a couple weeks ago, we were using this switch to explain how this works. I said I always bring my power when I'm switching power to turn something on and off. I always bring the power to the common terminal. So that's what I'm going to do. Since the power source is the battery, I'm going to hook the wire that goes between my battery and the switch to the common. So that way, whether I'm trying to use the normally open or the normally closed, power will be available. And so for electricians, they would call this here the line, because that's your power bringing it in. and they'd call this side the load because it's what's putting the load on the circuit. So for my load side of it, I have to think about my sequence of operation. What do I want to happen with this? When do I want my bell to activate? Do I want it to be activated all the time and then get switch turned off? Or do I want the opposite? Do I want it turned off all the time, and then whenever it goes into alarm, I want it to turn on? Well, with a water flow bell, I always want it silent unless water's flowing. So I'm going to use the open set of contacts because open means turned off. So I'm going to wire that right there. And now that I have all my wires hooked up, you see I'm going from common to normally open. Just like my monitor module, by the way, it's going from common to normally open. So now I can hook it to the battery, and I'm not working on a live circuit, but everything's hooked up. The LED light is turned off. And I'm going to set that back to 0 just so we can watch. Also, when this is in the pipe, you obviously can't grab this side of the circuit and move it. This little part right here, if I move that, it's directly attached to that paddle. So that's a way you can test it if you're trying to make it switch states real quick. But you saw every time I pulled on that, it turns on this LED light. So that would be ringing the bell. And you also see over here, we're going in and out of our alarm state at the same time. The meter's a little slower than the light. The light's a better status indicator. But that's, in simple, the way that you hook it up. So you remember the negative side went straight to the light. And then because we want the bell to normally not ring, we use normally open. Last week, we talked about air conditioner HVAC shutdown. We said we want air conditioners to always be turned on. So you use normally closed because the closed circuit is the turned on circuit. So in things like air conditioner, elevator recall, they want normally closed because they want those systems normally functioning, so normally turned on. And then whenever we go into alarm, we're actually overriding it and we're turning it off. So that normally closed terminal then opens up and it turns it off. In the case of a water flow bell, we're doing the exact opposite function. We normally want the water flow bell to be turned off. We don't want it ringing. And then whenever water does flow, it leaves its resting state and turns on. And so that bell is letting us know that there's water flowing somewhere in that building. And then whenever water stops flowing, the bell turns back off. This is the conventional way of hooking it up. This is the way it's been done for a long time. If you've seen it where we've used our just a dedicated NAC circuit and it goes straight from the power supply, chances are that was probably a Silent Night or Fahrenheit system. Those have intelligent, programmable, individual NAC circuits, so we can actually dedicate one of them as the water flow bell circuit, and we can do all this in programming instead of using this switch here. All the witchcraft and voodoo that is programming can do this switching for you. But if you're working on any other brand system or an older conventional system, then you're going to need to know this way of doing things. The other reason we do it differently with the Silent Night panels is not only is it easier for y'all to install, and anything we can do to make it easier and quicker to install is a good thing, but also those Silent Night panels don't have an auxiliary 24 volts on them. We have to program one of the NAC outputs to be 24 volts. And so if we're already programming one of the NAC outputs so that it can't be a NAC output and it has to be something different that's dedicated, might as well dedicate it to the sprinkler system or to the bell and make it easier for y'all. But if you're putting in, say, a IFP 75 or a Gamewell 7075, those are the same panel. I think that's the next series I'm going to do. We've done switches for several weeks. I think we're going to come back and I'm going to start getting into the different panels, and we'll do detailed videos on each panel. But if you're putting in one of those, you've only got 2 NAC circuits on it. One of them has to go to the NAC devices that are there. But a lot of times when we do that dedicated sprinkler monitoring, we put in a cellular dialer with it, and the Starlink ones we use are powered by 24 volts. So if we're using one of the 24 volts for the for that cellular dialer and another the other output is going for the horns and strobes, we have to have a way to trip the bell. So knowing how to do it this way, you can use that same 24 volts, that powering up that dialer, because it has the same battery backup, all the same everything. You can grab it, wire up a water flow this way, and even though there's only 2 outputs on the panel, you can accomplish 3 different tasks with it by knowing how to wire things this way. Also, Gamewell panels, as smart and wonderful as they are, they don't have the programmable NAC circuits, but they do have auxiliary power. So you can wire this up with Gamewell panels, Notifier, Firelight, any other brand out there. So if you're working in, like if we're doing a lease space and we have to add a sprinkler bell somewhere, or we're doing a school that has an existing system of whatever brand, and they're adding a sprinkler system in the school, and so we have to add a sprinkler bell. Knowing how to do it this way, this got pushed back here when I turned it. That's why that light turned on. Knowing how to wire it up like this to power your bell is a good thing to know. That's something that's going to be helpful. I think I beat Waterflow and Tamper as much to death as I can. If y'all have any questions, I'd love to hear them, love to talk about them. So fire away if you got them.
Hey, the 24 volts you were saying for the IFP, the 24 volts coming off of the panel, we're using it for the dialer, and as well we're using it for the 24 volts for the bell. Do you hook them up at the panel in series or parallel?
I would say parallel, just so that if anything happens or you got a bad wire nut or a loose connection, you don't lose your dialer. For anyone that's not sure what series and parallel is, that would be like if you have 2 sets of wires. So you have your aux power wire coming from your dialer and it lands under the terminal and it has its red and black. And then you have your wire coming over from powering your bell and it has the red and black there. What I'm saying to do parallel is where you put both red wires under the positive terminal and both black wires under the negative terminal, so that if anything happens to either wire, the other part of the system still functions properly. Wiring it in series would mean that it goes up one side of the circuit, wire nuts over to the other, hits the other device before returning to the panel. So if you had a bad junction somewhere or the wire got cut or broken somewhere, both parts of the circuit would actually stop working there.
And from what you were saying earlier, we stopped hooking up water flows like that, correct?
Whenever we have the option, yeah, we're not doing that. We're planning on using one of the NAC outputs from those Silent Night or Fahrenheit panels. But if you're doing a larger building that you've got a Gamewell system in instead of one of those Fahrenheit panels, you might still have to do it this way.
As far as hooking up the bell, though, that's
Correct.
what I'm saying. If you had 2 water flow switches, you can run it either way.
Yes. So 2 water flow switches would follow the exact same principle as this if you had to wire it up this conventional way. And then you would just run a jumper over, and you would jumper from this common to the second water flow's common. And from this normally open, you would run a jumper to the second water flow's normally open. And then that way, if either water flow went into alarm, it would activate this light. Let me see if I can.
Yeah,
go ahead.
the last question before you do that. Now, when we're using the new power supplies and you're programming that one of the outputs as a NAC circuit, do you still use the end of line or you don't have to?
If it's programmed as a NAC circuit, you still use an end of line. If it's programmed as an auxiliary power circuit, then you do not have to. So that depends on which way it's programmed. And that would be a thing you communicate with the guy doing your programming on site. So I know y'all can't see what I'm doing. I'm getting a wire ready so that I can try to use this other switch I have right here to try to treat it like the like a second water flow, because I only have one water flow here for today's lesson. Should be good enough. Okay, so in this, I'm going to use the black conductor as my common, and I'm going to use the red conductor as my normally open. And then I'll just jumper them over to this switch over here. So I hope I'm not losing y'all too much trying to hook this second switch up. I'll twist it over on the camera so you can see. So you see, I've just put it under the same screw terminals. I've got my black wire here under my common with this leg, and I've got my red conductor over here under the normally open. So I'm using this wire as basically two jumpers, and the stupid wire pulled out of the crimp here. Different one. I don't have my real wire crimper here with me at the moment, so I'm having to make do with this. Let's see if that worked. No. So then if I take this here, you can see this one is able to turn that switch on and off, or this one's able to turn that on and off. So this would be over here, this switch is acting as a second water flow switch. I just don't have two of these to wire the two together. But I'm using the normally open in the common terminal here and the normally open in the common terminal here. And it's just jumpering common to common and normally open to normally open. And then either one goes off, it activates it. And then if both go off, you have a really bad fire in the building and it still activates. Hope I didn't lose anyone with that. Did that answer all your questions, Ramsey?
Yes, sir. I know it was dumb, but I just had to put it out there. That's all.
Well, no, they were definitely good questions. There's just a lot of them thrown at me at once while I was trying to multitask and rig up the second switch. So I was hoping I got them all. I didn't recall. Did I lose anyone pulling the second switch into the equation? All right, I'm going to assume no answer means no, I didn't lose anyone. Everyone's got it. Are there any other questions? Even if it's just about switches, not about water flows and tampers particularly. All right, well, thank y'all for being here. I'll let you go. Hope you learned something. Hope this is helpful. Y'all have a good rest of your week. Y'all stay safe.